about creating some of those internal arrangements, the bulkheads. So this is essentially the top deck from the model that we're working on right now. And if we look at the layers, we've got surfaces mesh and the general arrangement bulkhead curves. And when we were looking at the strake-based models in Maestro, you could see a lot of the substructures are from one watertight boundary to the next. Now, there may be one module in there, or there might be several modules in there, but the watertight bulkheads are usually a boundary, and the strake-based models are typically built from the forward end of the ship to the aft end. When we're modeling in just elements and beams, we have more flexibility. We can still model along the length of the hull, going bulkhead to bulkhead, or we can go deck by deck. And since we're typically working off of the arrangement drawings, it's often easier to go deck by deck. So in this instance, we had the full ship brought in, and if you use the center button to click in the background here, you get this quick pop-up menu, and the upper left, that light bulb, is for show and hide selected objects. And if you open the extended dialog there, you can show and hide a lot of different things. You can lock layers, you can turn on and off cutting planes, and so forth. You can switch everything that's currently hidden with everything that's currently visible. And there are a number of different options here that you can just hover over to see what's available. You can have it show everything that's currently hidden, or just select certain things. So I'm just going to say, just reveal certain objects. So now it shows me everything that's currently hidden from all of the layers that are turned on. And you can see the full ship was in there. I just cut out one little piece of deck and made it visible and hid everything else. And this is what I'll typically do when I'm working on a new model. We'll have the hull surface. I'll put the main deck on one layer. I'll make a cut in the hull for the second deck, and I'll start generating the second deck, all of the bulkheads between the second deck and main deck, and the shell plating. And then I'll go down, I'll cut the third deck, and again, all of the bulkheads and shell plating between the third deck and the second deck, and I'll work in layers that way. So when I'm just working on the second deck here, I'll often import a copy of the general arrangements or the structural drawings to use as a reference for when I'm building the models, for any openings in the deck, as well as where the structural members are, all of your stiffeners, frames, and girders, as well as the bulkhead locations. Now, the first thing we need are the surfaces that we're going to generate the mesh on. So in order to generate the bulkheads, I'll just trace very quickly on there where the bulkheads are located. Now, in red from the general arrangement bulkhead curves, I just added a few additional bulkheads in the aft portion of the second deck here. These original ones were on a 20-meter spacing, and they represent the watertight boundaries. These are some of the additional internal compartments that we may want to model. Now, because the compartments are asymmetric, I have them modeled on both sides. For the existing surfaces, we could simply grab everything and run the mirror command. Pick a point on center line, 0, 0, and then go straight up. You can turn on and off whether or not the orthogonal restriction is enforced down here. There are some quick buttons for turning various things on and off. Object snap in Rhino is very useful. And these are the various options available for object snap, but it's turned on and off with this switch. They also have a handy thing called the gumball, which is this collection of axes, which is very convenient for moving things around the model, as well as extruding things or rotating them. They can all be done from this gumball, and that can be turned on and off from this button in the lower bar. So the general arrangement curves that I put in here, you can set different colors very easily by layer. And by default, when you create things, they get colored by layer, so you can change the entire layer very quickly. But you can also set these, and I have these grouped at the moment under the standard menu. Grouping is very handy, especially when you're dealing with a lot of curves, which we will be coming up. So under the standard menu here, and of these toolbar tabs listed at the top, And I should say your screen may look a little bit different than mine because as you can see, I'm using Rhino 6 and I believe you all have installed Rhino 7, but it should look pretty similar. But I tend to use the standard tab a lot and the mesh tools tab. And there is also on the visibility tab the ability to create and enable and disable clipping planes, which can be, once your model gets a little more complicated, that can be very handy. It's essentially the same thing as a cutting plane in Maestro. But on the standard menu, this group and ungroup is extremely handy because it also helps with limiting your selections. You could see when all those curves were grouped, if I were to select by dragging a window, and in Rhino, if you drag a window to the right, it selects everything that is completely encompassed by the window. And if you drag right to left, it uses a crossing window. So it'll select everything that has even a small part within the border. So to prevent some of the curves that I've created, if I create a large set of curves and I want to preserve them, a lot of times I'll group them so that I can drag a smaller window to grab all of the curves that I don't want to save. That'll be a little more clear once we get to the other model. And for selections, you can select by type of object with commands. So if you type SEL and then select curve, SEL-CRV is very handy. And it'll select all curves from all of the currently layers that are turned on, provided they are unlocked. If you have a drawing in there that you want to use strictly as reference, and you don't want to be able to select things from it, when you pull in that drawing layer, you can lock it. I'll have to make my surfaces my current layer, but then if I lock that bulkhead drawing layer or the G8 bulkhead curves layer, I can no longer select those curves. I can select other things, but those are on a locked layer, so I don't have to worry about selecting, deleting, or moving those pieces of reference geometry in there. So go ahead and unlock that. Select points is another one that we'll be using a little later. So SEL PTS is select points. And your various selection options are available under Edit, Select Objects, and then there's points, curves, lines, polylines, and so forth. Surfaces, polysurfaces, and extrusions is what we're about to use here. So if we select these curves, and then with the gumball, if you click on the arrow, and you can always go into the help to get guidance on exactly what the different features of the gumball will do, because it can do a number of different things. It can scale the object, it can translate the object, extrude it, or rotate it. To move it in a direction, you click on one of the arrowheads, or you can grab the arrowhead and drag it to move it. If you just click on the arrowhead, you can specify a distance. So if I move it 3 meters, it'll just simply move in that direction, or if you do -3, move it down. The thing I like to use this for is like when I'm creating these bulkheads, instead of grabbing the arrow, if you grab this small dot, it'll extrude those objects. So it took all of those lines and just extruded them into surfaces. Now the lines are still selected, so I could delete them now if I didn't want them anymore, but I'm going to hit undo on those. And instead, what I'll do is click on the dot. And I know this deck is 5 meters high, so if I give it a 5, it will extrude those bulkheads 5 meters. And now they go exactly up to the main deck. Now this particular hull, if you look up at the forward end, it does have some shear, but only at the forward end. I know that back aft, it's a flat deck and it's 5 meters above. The nominal dimensions of this ship were 160 meters in length and I think 16 meters tall overall, but 5 meters back aft. And when I drew those lines for the bulkheads, because I knew the sides flared a little bit, I drew them extra long so that I knew I would get a complete intersection with the hull. Trim them, and this is back in the standard menu here. You've got options to either trim or split. If you trim, it'll throw away the extraneous portion. If you split, it'll just divide them into 2 new surfaces. So a lot of times when I'm dealing with lines, I'll split them, and sometimes with surfaces as well. But in this case, I would select my side shell and tell it to trim, and then just delete the outside portions. And then do that on the port side. And this is another thing that's rather handy in Rhino is when you hit enter, it'll repeat the last command. So we just executed a trim previously. So if I either hit the enter key or, as I mentioned earlier, the right-hand mouse button is a shortcut for enter. So I can just hit the right-hand button and it'll say select your cutting objects. So I'll now select this side and I'll hit the right-hand mouse button again to enter. And then we can just delete those extra pieces and then hit enter again or right click to complete the command. So now we have all the bulkheads that we need for that interior arrangement. And once we have these surfaces available, then we can go ahead and start meshing them. But that was typically the procedure that I would use for generating my internal bulkheads. If you are pulling in geometry from a 3D solid model program like ANSYS, and when we get those solid plates in, we need to create a mid-surface model from them. And some programs will do that automatically. FEMAP can do some mid-surfacing, as well as we also use HyperMesh. Both of those can do mid-surfacing of solids, but each of them can have some trouble with some of them, especially things like a twisted T-shape, a shell stringer. As it goes along a twisted portion of the hull, they have a lot of difficulty doing the mid-surfacing on those. And in Maestro, what we would typically be modeling for those stringers is just a single beam. So we don't actually need the surfaces for those smaller stiffeners. We would just need the trace where it contacts the hull. But for the hull shape itself, if you don't have a clean surface model already, what you can do is fit a surface to a collection of points. There's a feature in Rhino that allows you to fit a surface from points, because I know when you have a compound curve on the plate, when it exports, at least from Ship Constructor, you get some of the surfaces had 10 thousands of small triangles for the surfaces. And I basically converted that to a point cloud and then fit a surface through them. And when I compared the fitted surface to the original points, I was getting less than a millimeter difference. Actually, it was the tolerance, because the plate was pretty smooth, was about 1/10 of a millimeter. So we were pretty happy with the fit. At any rate, this is just a quick way to generate some of the internal geometry for meshing.